Yeah, it says we're live.
All right, I hope we're live. I hope I should check that. Let's see.
Could text Nadia to check. I don't know.
Yes, that will work. I'm sure I will get a message soon if this does not work. So hello everyone, welcome to the third Ladies Storm Hackathon interview prep session. We'll be covering bit manipulation and brain teasers with Jake here. Jake, why don't you introduce yourself?
Hi, everybody. I am a junior at the College of New Jersey. Um, I'm here to learn, so I guess that's about it.
Terrific. Okay, now let's see here. Uh, we are having slight technical difficulties. Jake, are you able to share your screen?
Wait. Screen share. Yeah, I can.
Oh, okay.
So I'll just share
Um,
the Twitter
if you share
password.
your screen, that should work. I'm for some reason unable to do screen sharing myself. Oh, that looks beautiful.
That look good?
Terrific. Yes. And I think everyone should be able to see that. Yeah, the text looks fine.
Okay.
Terrific. So to start off with, you don't have to pick C for your language. I just chose that to start off with.
Oh, yeah.
So you can pick whatever language you want for our interview, keeping in mind we'll be doing mostly bits and bytes and stuff like that. So anything you're comfortable with.
Pearl should be fine for me.
Sweet, okay. So, all right. So Jake, I assume you've studied a little bit for this interview.
I studied some, yeah. A little
Good.
bit studying on bit manipulation, and done okay at brain teasers.
So what can you tell me about?
You just cut out, so I can't tell you much. Hello?
Oh, are you still there?
Yeah, are you there?
Yep.
Okay, I missed it.
So what can you tell me about bits and bytes as they relate to machine and with programming?
I mean, obviously, all computers are binary based, so bits and bytes are kind of what compose the data structure. Um, if you want to talk about numericals, I mean, a bit is essentially just an on or off toggle, and it can represent numbers and a bunch of other things. It can be used to do quick math in most programming languages. So there's that.
Yeah, that sounds good. So if I have some bits representing something, what sort of operations can I do on these raw bits?
On the raw bits, you can do exclusive ORs. I know I've played with some. You can add them. You can multiply them. If you shift one to the left, you can double them. If you shift one to the right, I think you cut them in half. What else can you do? You can do regular multiplication and division on them if you want to take the time to do it.
Mhm.
And addition and subtraction, obviously, as well.
Yeah, that sounds pretty good. All right, so let's see if you can apply this knowledge you have. So recently, hypothetically, I've been contracted by a design firm to design a new CPU, and it has to be a very tiny CPU because it's going to be implanted on lights to track their movements. So I've come up with this cool design, but the company contracting me wants to verify it using Perl because they don't want to spend millions of dollars manufacturing this if there's a bug with the design. So I have to implement all these methods to check the operations of the CPU and ALU in Perl. And one of the operations I need is working on the two registers my CPU has. So right next to the CPU, there are two registers that store integers. And I only have two because it has to be a small CPU. And I have an operation that swaps these registers. So the contents of one register goes to the other and vice versa. But I can't use anything else for this because there's no third register, and there's no knowledge of memory or disks or anything like that. So I need some function to simulate swapping these registers without having an intermediate variable or an intermediate register to hold these. So could you write some function that takes in two values and swaps them without using a third value?
I think I should be able to do that.
Yeah.
Let's get rid of the sample code.
All
Uh,
right.
right here, we're going to use strict, use warnings. So that's just going to make sure that I don't forget anything. Because Perl will compile and not show you errors if you don't use those. So good to have.
Terrific.
Uh, my do this. And then clicking. Okay, so those are going to be the two, what I'm going to use to take in values right there. And it's going to be a function called add. And 1 minute, 1 minute, 1 minute, 1 minute. Okay, so how am I going to go about composing this? And we're going to do these. RB0 and RB1. Actually, if I'm being smart, I should pull them outside of that. X. Add. There we go. Okay, so there's that. Now we just need to switch the input out.
You broke up there for a second, sorry.
So now we should just need something that's going to switch these inputs out, basically.
Yes.
So, in order to do that, it's all going to be taken in binary. How do I do without crossing a third parameter? Incoming, that's outgoing. What exactly could I do?
So my ALU, again, only does binary operations. So what sort of operations do you have at your disposal then?
I've got add, subtract, exclusive OR. There's the basic ones.
You'll have also and, or, and not. So you can use those too if you wish.
Okay. Let's see. How am I going to go about doing this? I'm thinking about comparing the two, to be perfectly honest, because that's the best way to do it, I think. Is to compare the first input to the second input and change them out on a bit-by-bit basis.
All right. If you think that'll work, we can take that approach.
That's what I'm thinking. I'm not sure how to implement it yet, though, so I'm taking my time. I don't want to make any mistakes here. Let's see. Without using a
All right. So with these operations at your disposal, you could have multiple operations chained together. So you could AND some values and then OR those with something else, and then do an XOR on that, an exclusive OR. But these operations have some properties. So for instance, what are some of the properties of doing operations on binary values?
What do you mean by what are some properties of them?
So for instance, all right, for example, if I have a value A and value B, and I do A and B, binary AND with B, would that be the same thing as doing B and A?
I think the result would be the same, yes.
So you do have that, so it looks like at least ANDing has the property of being commutative, so you can swap the places of what you're acting on, and it'll have the same result. So that's one thing you can do. You can sort of move around your operators. Let's talk about exclusive OR a bit, because you mentioned that as one you were sort of familiar with. So if I were to exclusive OR a value with itself, what would my result be?
Exclusive OR a value with itself, your result would be 0. It's all zeros. Because they're obviously all in the same bit, so you can't have them both be active at the same time.
So that's another thing to think about. In the same way, what would happen if I ANDed two of the same value together?
ANDed two of the same value together. I think you'd get the same thing out that you put in.
So you should sort of think about these properties as you're thinking through this problem. because you do have this very limited set of operators. So you might have to chain some of these together to get the result you're looking for.
That's what I'm thinking. I'm just trying to figure out exactly which ones I need to chain together.
Mm-hmm.
Okay, so I'm going to get out all of the values from A and transfer them into B.
All right. So if we think about this, we only have two places to store these values. So our first operation will essentially have to be storing some operation in one of those values. So let's start with that.
Okay, so we're going to do my is going to be at I and is going to be equal to. We'll take in our values. Now then. Suppose I couldn't just output the them in reverse. That wouldn't really work.
Not quite.
Let's see.
All right, so let's see. Let's think of another property. So we know that we can switch up the order in which we operate on the variables. If I were to, let's use XOR again. If I had three values, so I have values A, B, and C, and I'm going to XOR A and B, exclusive OR, and then I'm going to take that result and do an exclusive OR with C. So would that be the same as XORing B and C and then taking that result and XORing with A?
Give me a second to think. You XOR with B and then you XOR with C. Would it be the same? I think it would. Yeah, it would be the same.
Mm-hmm. So we have that. We have the property of associativity. So it doesn't matter what order you take the operations in if you're doing the same operation.
Yeah, that does make sense. I was actually working on a similar problem to this earlier, and I just can't quite wrap my head around the issue, to be honest.
Mm-hmm. It is a little tricky. Okay, a lot tricky. Bit manipulation is definitely very mathematical, not exactly how humans normally think, so it can be a struggle. But,
that being said, I'm not going to give up on it.
Of course not, of course not. But now that we know this property of associativity, we know if we were to operate on these two variables some number of times, it doesn't matter what order we operate on them if we're using the same operand.
That is true, yes. So I need to figure out how to use that in order to fulfill this. So if I exclusive OR, that's not going to work.
Well, let's focus on one to start out. So forget the swapping both. Let's see if we can get one of the values in another value using binary operators.
Okay. So we need to get one of these values just transferred over to the other register and ignore the second value?
Yes, yes. And equals is cheating. I mean, yes, you can just do equals.
That's a way to do it, but I don't think that's okay.
Why don't you throw in a couple operators there? Eventually, it will come out to the same result as equals. So using your knowledge that commutativity, associativity, and that if you XOR an element or AND an element with itself, it's If you add an element with itself, it's the same, and if you XOR it with itself, it's 0. You can use that to help you out.
I should be able to, if the second register is empty, I should just be able to say, what is it, we're calling it N, so it's $, that's not a $, that is $N 0, which would be the current. We're only feeding in one value right now, so this is.
So we do have the two values. We still have the two values. It's just we're going to overwrite one of them right now. We don't really care about swapping. We're just going to put one of them in the other one and forget about the one that was just overwritten.
Okay, so then this should be $, not $. There we go, $, and one. Okay, so that should be exclusive ORing the two together should make one equal to the other, because the only value that that really changes is the 1. So as long as there's a 1, the exclusive OR should carry out as true.
So that you're saying that would be.
I think that would be the equivalent of transferring them over.
Well, let's think about it. So you have, let's see, let's come up with some examples. Let me jump in the coder pad, actually. That would just be a smart decision. All right, so if we have two values, maybe 1, 1, 1, 0, and 0, 1, 1, 0. So here are the binary strings of the integers we're passing in. So if we were to XOR these, we would get the first one, since two different values, would be 1, and the rest would be 0.
Second two, and you get all zeros after that.
Sorry?
I was agreeing with you, yeah. So if I have something like this, and it's 1, 0, 1, no, that's not a 1. 1, 0, 1, 1. And I exclusive OR it with just a straight 0 set, and it shouldn't be an issue.
Right. Yes. Yes.
And for the previous problem, I should say, I was assuming the second register was empty since we're only dealing with one register now.
Right, right. Let's not assume that then. Let's assume there is some value in there, but we don't care about it right now.
Okay.
This is good. So if you do XOR with 0, then you get the original number. So how would you create 0 from this other value?
Let's see here. I'd have to chain a few together, I think. I'd have to make it all ones first, and then no, wait, that wouldn't work.
So this is good. This is the right idea. So XORing with 0 will get you the value. But if you have some value, it doesn't matter, any value, you have to XOR that with something to get all zeros. And what would that be that you XOR with?
You'd have to XOR it with itself, wouldn't you?
Mm-hmm.
Yeah. So if I did copy this, semi-sloppy coding, but okay, and one this with sign, and there we go. So that should give us a second value of 0. Then when we exclusive OR the first value with it, we would get all the first values.
Yep. All right. So that's a good starting point. I like that. So if you have XOR with 2 values and then a third value, then you're going to get the third value. So that essentially solves putting one value in the other register, but not swapping back yet. So we solved sort of half of it with this, but not the other half.
Yeah. So now that's where I was kind of getting tripped up before, is that I can't think of a way to store the data without erasing it.
Mm-hmm.
At least that's the tricky part of the question to begin with.
Right, right, yeah, essentially yes. All right, but let's take it one step at a time. So it looks like you already have a good first step, which is XORing the one value with, and then your second step is XORing the initial value to just kill off that value and get the original value.
Yes. So that's where we're currently going about it.
Mm-hmm. So those are sort of, you can break those into 2 steps. So the first XOR and then the second XOR. You could combine them into one step with two XORs, but you could also break them into two separate steps. And let's stick with that. Let's break them into two steps so we can break down how we're thinking about this.
Okay.
All right.
Let's see. Probably put something in here to actually hold those values, just for the fun of it. Okay.
And remember, no intermediate values. So
Yeah, no, I'm not using them to hold it. I just want to have a record of it. So that's A equals that. You don't even need to do that. You can just do this. No. $sign A equals. This is $sign N. That would hold the values right now, but that's not going to hold it when we do the when we do both of the registers together.
All right, so it looks like when you do this XOR, this 1 and 1, you're killing off 1, which is kind of unfortunate.
Yeah.
So we can actually think about this if we forget about the intermediate values and try to go back to swapping. That would sort of be something like this. So you're storing 0 in 1, which is half the swap.
That would make sense, yeah.
Yeah, so that's sort of half the problem. So we've stored one value in the other, but your first step killed off the initial value, so that doesn't quite work.
No.
So one of the properties again of these binary operators is associativity. So you can do either of these steps in any order because it's both XOR.
Yes.
And you'll notice that if you XOR these two different values if you pretend that the first step doesn't exist, if you XOR these two values, you still have the original data because then you could XOR it either with N1, which would give you back N0, or N0, which would give you back N1.
Yes.
So that seems like a good first step. So if you move that to the first step instead of the second step, you might be able to make better progress.
Okay, so let's get rid of this guy then. You're gone, and this. Exclusive or one with. Whenever you do that, I could produce exclusive or one with 0. Wouldn't that make sense?
That looks good.
Yeah.
Yeah.
Now we have two identical steps, though, so that step's kind of null and void.
Right. Let's think about this. So your current two steps, what exactly are you storing in N1?
In N1, I'm storing the exclusive OR of N1 and N0 right now.
And then the next step would store...
The next step would store the result of exclusive ORing it with itself again, so it would return 0, actually.
Would it?
Wouldn't it? No, wait a minute. It would. I think it would. No, it wouldn't, because it changes every time.
So remember, you changed what N1 is.
I did, so it wouldn't be 0. It would be... You'd be returning N1 then, wouldn't you?
Mm-hmm. So
yeah.
You're storing N1 in N1, basically, is what these two steps do. So what if you wanted to store N0 in N1? What would you change about the second step?
About the second step, I would change... A minute. I would do one of those, I think.
Very nice. So that's half the swap right there. So those are good two steps. That does half the swap. But we do need to do the other half of the swap, which is get N1 into N0.
Yes.
So this is a good first step. I like this first line you did, N1 equals N1 XOR N0. But if you immediately do the second step, then you lose N0. Or you lose N1 because you stored N0 in N1.
Yes.
So is there a step you could do between here to save that value?
I'm sure there is, and I need to think about it.
Mm-hmm.
Let's see. And it? No. Let's see.
So we know we can't store it in N1 because we're already using N1. So whatever we do, we have to store it in
Yeah. And oop, come on. Yeah. And we'd store, would it be? Is that right? I don't think it is. Something feels like that's wrong.
So to make this a little easier to think about, I'm going to expand this N1 to the original statement.
Okay.
So you can think about it now in terms of the original input values. So the second line here, think about in terms of the original input. So this is what you're technically doing.
Yes. Okay. Yeah. That makes sense. Then if I wanted to store that data in N0, I could store exclusive ORing. It would store
Would store.
N1 in there, wouldn't it?
Yep.
And then now N1.
All right. So I like the second line. We're gonna stick with the second line. So I'm gonna put it back like this. So this is the actual code-wise correct way to display it. So now you have, as of the second line, you've stored N1 in N0.
Yes.
And N1 contains the original N1 XOR N0.
Yes.
So essentially, this one down here expands to that using the original values, if you think about it with the original terms.
Yes. So that should store N1 down in the, oh God. Yeah, that should store N1 down, or yeah, N1 gets stored in N1.
So why don't you go through this line? What does this actually store in N1?
Let's see here.
Because remember, the commutative and associative operations.
Okay, so then it should be storing, first off we have to do the ones in the parentheses, so it's going to store the exclusive OR of N1 and N0 and the exclusive OR of N1 and N0 again, and if you do that you're going to get 0.
Mm-hmm. So that's not quite right then.
No. What?
So it's very close. So what would you do if you wanted to get not 0 but N0 out of this? What would you change out of this line to just get N0?
To just get N0?
Mm-hmm.
I would get rid of this.
Mm-hmm.
Yeah, that would.
Great. And now, remember this is the original value, so we can substitute back in the operation, which is now N1. So this is now N1. N. All right. So let's go through this. Do you think this would work?
Let me look. Let's see here. N1, so you're storing the exclusive OR in N1. That makes sense. Then you're storing N1 in N0, so that makes sense. And after that, you're storing N1 in N0 in N1. Yeah, that does make sense. That should work.
Yep. So yeah, that looks pretty good. And that is it. That does solve it. So that's very good.
Yeah.
All right.
Yeah.
Again, a little tricky to get there. I'd recommend you look up XOR swap after this, because when you see it again, it'll probably make a lot more sense now that you've worked through it.
Yeah.
But we can see here what you're essentially doing on this last line is you're taking the original N1 and N0, which is now in N1, and XORing that with N0, which kills off N0, which kills off kills off the N1 and gives you N0 stored in N1.
Yes, that makes sense.
So that looks good.
Things looking pretty. We're going to do that.
All right, I like that. I like that solution.
It worked out. Thanks for walking through it with me.
Yeah. Again, just a quick recap of binary for everyone. We have AND, OR, XOR, and NOT, which are 4 major binary operators. And you can have different laws about how you can use those operators. So for instance, if you XOR A and B, it's the same as XORing B and A. A, B, C can be either A XOR B, XOR C, or A XOR B and C. So there are these kinds of laws you can use to manipulate things and make it easier to understand. So now that that's fresh in your mind, let's look at another similar situation. So we're going to say we have some list of numbers, and it can be any. It's just a list of integers, and there are a bunch of these integers. It's a very, very long list. But what ends up happening is every integer in this list is going to be repeated twice. So wherever you encounter like a 5, you know there's going to be exactly one other 5 in the list. Except for one number, some unknown number, which has 3 entries instead of 2. So somewhere in this list, if we make a small version of this list, we see here there are 2 5s, 2 7s, and 2 9s, but 3 3s. So I want you to write a function that will take this list and determine which value appears 3 times.
Am I allowed to use, what's the word I'm looking for? Diddly. That's not right.
Well, I'll give you these lofty constraints. I want you to do it in linear time and constant space.
So I think I can use hash tables. Yeah, that should work.
Hash table would be not constant space. It would depend on how long the list is.
Oh, okay.
So I want you to stay in the bit binary mindset for this one.
Okay.
Because you are using constant space, so you can't afford to have some number depending on how many entries are in the list.
Okay, that's fine. Then next, I will do this. Can I just start another sub down here without?
Yeah, go right ahead.
Okay, yeah. Call it for some reason. And we're taking in that. Do you want me to deal with input, or can I just write the function for it?
No, just go ahead and write the function.
Okay, I was going to say, do you need std in or anything?
No.
Okay, I was going to say that's a bit excessive.
This will be simple enough that we can just look it over and know if it works.
Yep. So I'm thinking I can't dynamically allocate. You're saying I can't dynamically allocate space, basically, right?
You can, it just can't depend on the number of input items in the list.
Okay.
You can't say create another list that stores elements, because that would depend on how many elements are in the input list.
Okay, but in Perl, if I made an array that has 100 elements in it, it would be constant space, but you don't have to put all the elements. That would be fine, correct?
True, but this is an extremely long list, perhaps. Okay. Very long, maybe too long to even fit in memory.
So it's not just this little list of 7 characters, like 10 characters down here.
It could be much, much longer.
Okay. Well then.
And remember, there will always be exactly 2 elements of every number except for the one with 3.
Yes, and we have to do it in linear time, which is also making it more tricky. Just a ON, right, for time?
Yep, that's
Okay.
right.
So how would I go about doing that? Originally, I was going to make a hash table that just counted up totals, but that's not going to happen anymore.
No, sorry.
Let's see what we can do. So if I did can't go through the array more than once, which makes it tricky. Let's see. Can I sort the array?
That would be more than linear time, unfortunately.
Yeah, I forgot about that.
What were you thinking, though? Why would you sort?
If I could sort it, it'd be easy to tell if you could pick a given character and say if the immediate next character is not, uh,
Mm,
like you could say if it's 3 characters in length, you'd get 3 in a row, basically.
I see, I
It's
see.
easy to detect a pattern. Let's see. So I can't sort the list. I can take it in. I'm going to use @n again. Or a semicolon. Hmm. So, I can't just compare them because I think that's not going to be linear time anymore.
Um, Probably not.
Or let's see, and I'm not sure if you're familiar with Perl, but if you no, not that, and if you give the original array in as a argument or in as a number, it gives the array size. That's what this @n means.
Ah, cool.
Yeah, it's a nice little tool to have.
Mhm.
And then we have it has to be $ I plus. And that should do this.
All right.
And we've got $n. I
So if we think about what we did in the book, you were using binary operators along with some number of inputs to sort of mask each of the inputs. So could we apply the same strategy here?
Could we? I'm sure we could. Can you repeat that one more time?
Sure. So in the last problem, we started thinking about how we have these operators we can apply like in a row. So for instance, technically on the third line of the add routine, we applied n1 XOR n0 XOR n0 because n1 technically was changed in line 1.
Yes.
So we were able to chain these together and sort of use. So we ended up getting rid of n1 and just ending up with n0.
How does that help me here? They don't want to scan more than one variable. I have a feeling this might not be linear time what I'm about to do.
Let's see.
Oh, I need to have a nested for loop. What am I doing?
In that case, note it is not linear time.
Yeah,
Sadly.
figured. What can we do in lieu of that? Certainly did a good job of picking tricky ones. I'll give you that much.
Well, thank you. I tried. I knew you were capable of this.
I think I can still do it.
Oh yeah.
Just need to think. Let's see. Hmm. So do you work with this kind of stuff a lot?
Sorry.
You work with this sort of stuff a lot, or is this?
Um, not especially. I will admit I don't see much of the binary manipulation and brain teasers. Much. I think that's I've heard it a few times in larger companies like Amazon and Microsoft and interviewing at those places. But I work at Thumbtack, a startup in San Francisco, and I know a lot of other companies here, when they interview, they focus a lot more on software engineering versus algorithms and bit manipulation. There's definitely some of that, but a lot of the concern is, can you write quality maintainable code, as well as are you smart enough to solve these sort of problems?
Hmm.
This one is actually, I don't know if I should say that. This came from a larger company, this question. I know someone who was asked this question.
Let's see. Certainly is a tough brain teaser. There it is. Nested for loop won't work. God, everything I've ever thought of is more than linear time for this.
So are you familiar with accumulation?
I've never used it actually. I
All
know
right.
it's accumulator
So
in a CPU, but that's about it.
since we have content space, we really can't afford to start like tracking lists of things or sets of things. So what you'll probably need to do is accumulate, and that is having some starting value and then applying some operation to that value and some element in the list, and do that for every element in the list. So that's accumulation. And that allows you to just keep that initial starting element in memory and then modify it as you go across the list and end up with that modified value. So that only takes the space that that initial value takes up.
Only takes up the space that initial value takes up.
So for instance, if you were to write a function that would sum a list, you would probably start with, I'm going to set sum equal to 0, and then for each element of the list, I'm going to add list element I to sum. So that's accumulation. So you just start with sum at some value, then you act on sum for each element in the list, and you end up with, again, sum, which is the same value. It hasn't changed in size. It's constant space. So you can take the same sort of approach here. But the trick is, what operation are you applying to your starting value, and what should the starting value be?
I see what you're getting at. I'm just trying to figure out what the starting value should be right now.
Mm-hmm.
Let's see. Wouldn't be 1. Wouldn't be the initial value in the array. It could be 100's not going to work.
So there are two stages here. You know that you need something that's a starting value.
Yeah.
And then you need to know whatever operation you're doing. So it might be easier to think of the operation before you think of the starting value. Because if you don't know what you're acting on, then it's very hard to pick what you're starting with.
Makes sense. Let's see. Could it be the summation of all the values in the array?
Well, if you sum them, how would you figure out which one is the odd one out, which one has the 3 value?
Oh, you're right.
So if we think about these binary operators we were talking about, we talked about associativity and commutativity, where commutativity says it doesn't matter what order we apply the same operation in, and associativity says essentially the same thing. It doesn't matter what order. If we have 3 different values, we can apply the order. It's associative.
Completely cut out for like a solid 5 seconds.
Oh dear. All right. So commutativity and associativity essentially say it doesn't matter what order I apply this binary operation in, it's going to have the same result. So if I have some amount of like integers, for instance, that I'm applying some binary value to, it doesn't matter what order I do it in, it will have the same results.
Mm-hmm. It's not the size, it's not numbers in the array.
The array is integers, by the way.
Oh yeah, that does. I should have asked that from the beginning because if it was doubles or something, I don't want to deal with decimal points in this.
Oh no, it's all just integers. You can assume.
Huh.
We also discussed the XOR inverse, where if you do you remember what that is?
The XOR inverse?
So what happens? What we did something with XOR and got 0 as a result. What was that?
If you XOR a number with itself.
Yep.
Oh, I think I might have figured it out.
Oh, good.
I'm not trying to put it into code yet, but I think if I XOR everything in the array with itself, the only one remaining is going to be the one that has 3 values.
Sounds good.
So I need to figure out how to implement that now.
We can not deal with the implementation. You got it conceptually, which is the main issue here. So you understand why that works.
I do understand why that works, yes.
So explain it back briefly.
Okay, so you exclusive OR every number with its pair in the array, and that's going to make every number equal to 0, but there's one that's got 3, and when you exclusive OR a number with 0, since the previous 2 will have been used up, the third one's going to maintain its value.
Mm-hmm. Yep. Yeah, that's it in a nutshell. Well done.
Thank you. I'm pretty proud of it.
Yeah, that is a. I don't think I'm allowed to say what company that's from, but that's very good. I think we've been spending like, oh my God, it's been like 50 minutes just on binary operators, and we haven't even covered brain teasers. So let's stop doing binary data, because I'm sure we're sick of that by now. Let's do something a little more abstract and less frustrating, perhaps. So have you studied, I don't know exactly how you studied this, but have you studied brain teaser solving?
Yeah, I've done a lot of them in my life. I had to get tested for a few things that involve those, so yeah.
Sure, all right. Well, in that case, I hope you haven't seen some of the ones I thought of before. But, okay, let's see. So we can still use the coder pad, even though we're not coding here. So we have this nice dish of pie, not the mathematical pie, the edible pie with apples in it. Yeah. And we want to cut this pie into pieces, and we have a lot of people, so we want to cut a lot of pieces. So we're going to take a very long knife, straight cuts, and we're going to cut the pie once, and we're going to cut it in half. Because we're cutting straight through the pie, it doesn't matter where, we're going to cut it in half somehow. Maybe not equal halves, but we're cutting it into 2 pieces. And then we're going to cut it a second time, and when we cut it again, we could cut it just on one side. So we could take, like, if we cut it down the middle and we have 2 pieces that are equal, we could just cut it on the left side, but we want as many pieces as possible. So we're going to cut across both pieces, and now we're going to have 4 pieces. And then we're going to cut it again, and yeah, we could cut it through where the other 2 cuts are, and that would give us 6 pieces, but we could also just do a different cut angled somewhere else, and we'll end up with 7 pieces. So what we want to do is we're going to cut this pie 6 times, and we want to know how many pieces we can possibly get. We want the most number of pieces from 6 cuts of this pie.
1 second. I need to find a piece of paper because I'm going to need to work this out on.
That is advisable. Ooh, I
Okay.
wonder, can I draw in Hangouts? Let's see.
There we go.
I guess I can.
Okay. So we've got pi. And cutting it, and cut it again, and that gives us 4. And cut it off center, and that's 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7.
Oh my gosh, I cannot draw.
You're cutting across as many edges as possible. Basically, the key to this problem is cutting across as many edges as you possibly can at once.
Essentially, so the problem is you want to cut as many pieces as possible with straight cuts.
Yes. No. Yeah. You can't like curve it around and be fancy with it.
Right.
Let's see. 1, 2, 3, 4. The pieces don't have to be equally sized, do they?
No, definitely not. Actually, let's see if this whiteboard will work. Yes, it sort of does, except the glare is awful.
Well, man, I'm not even on the Google Plus Hangout thing anymore. I'm still on.
Well, for everyone else's, I'd say benefit, but this is some really bad glare. Hang on.
Individual call. Yes, I accept the terms and conditions. Take me there.
Oh, well, that kind of works.
How's it going? Yeah.
So we have this, yeah, for those of you who couldn't see this, because Jake's not actually drawing, we have this pie. We're cutting it once, just across somehow, cutting it into 2 pieces. Then we'll make another cut. Now we have 4 pieces. And we could make another cut across the center to give 6, but we can also cut, I don't know, like this. And now we have 1, 2, 3, 4, 5, 6, and 7, this extra piece hidden sort of near the center in this example. So we're going to keep cutting it 6 times, and we want to know how many pieces we can get.
I think if I've done this right, I've got the answer.
Oh, all right. Why don't you talk through it?
Okay, so I can't show you a picture. I can show you a picture, but it gets really like using a marker. It's not very legible. But basically, the key was to cut through every edge every time, so that you can get the maximum number of slices.
Yep. Yep.
So I ended up with. Let me count it out so that I 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, I think 20. I'm pretty sure I got 20. Is there any chance that's...
Close. I mean, it could just, I have no idea how you managed to draw 6 cuts and actually be able to see the pieces. So can you sort of explain the general reason why cutting across all the edges works?
Yeah, so the more edges you cross, the more pieces you create. So as from your first example, you showed what happens when you get up to 3 slices. You can cut 1, and it'll give you 7 instead of 6.
Yep.
Yeah. So basically, for every edge you cross, you're adding more slices to it, or more pieces of the pie.
Mm-hmm. So if I have like 2 edges, I guess for this case, and I cut across them, how many pieces do I create?
2 total edges, you'd have 4 pieces total.
Oh, sorry. What I mean is if you have 2 edges already and you're going to make another cut, how many pieces would you create with the cut? Not how many total, but how many will you create?
3 more slices total if you added a 3rd cut to it.
Mm-hmm.
Is that what you're asking?
Yes. So what if I added a fourth cut? Then how many pieces would I add?
I believe you'd be adding 4 slices. Wait, let me math. Before I make a fool of myself. Adding a
All
4th
right.
slice. 1, 2. Yeah, so you're adding 4.
And if I were to do another cut?
You'd be adding. It's basically just you're adding n to it.
Terrific. All right, so if let's go back to the coder pad for a second.
Uh,
And can you write me a function that, given the number of cuts, gives the maximum number of pieces?
Given the number of cuts. Oh, Are you still screen sharing? Can you see me?
Oh, sorry. You're screen sharing, yes. We see the coder pad.
Okay, cool. So I spaced out and forgot what you asked me to do.
Um, go ahead and write a function that takes the number of cuts to make and returns the maximum number of pieces we can have.
Number of cuts to make. Oh, okay, this is going to be fun. It's a little factorial program.
We'll see.
Let's see how to go about this. We're going to start off with my $sign. I don't care. P, pi. Equals, actually it should be an @ sign. I'm going to do @p. And that's just going to bring in any arguments that we have so that it can give us the number of slices. And then $P0, that's not a 0. $P0. Actually, I can do this. Okay, so the total number of slices is going to be that. And I just want to store it as a variable on its own so that I don't forget it. So that I can manipulate it without manipulating the original data. So we're going to do that. And we're going to say, I think the easiest way to do it is recursively. So it's going to be total equals, and then total equals I total minus 1.
Mm-hmm.
Then that, and then just a base case for it. Okay, so then in the end, when it hits the return line, it'll return the total, which at this point eventually will be 0. Oh, I should make a thing that actually says that though. Total is greater than 0. Okay, so that should do it, I think. Oh, that's not an else. That should be it. There we go.
All right. Oops.
So unless I made some.
This subtotal, I think, from up top is very syntactically wrong.
Yeah, you get a compiler for using that.
You can comment that out or kill it, or it doesn't matter.
I'll comment it out just for the sake of saving it. It's supposed to work, but it's not, so then I'm just going to delete it.
All right. And I don't trust the syntax highlighting for Perl on here, so it maybe works, maybe didn't.
Okay, so if you want to walk through that, it's basically just saying your incoming, when it's called, the incoming total is going to be, whatever it is, and that's going to be the number of edges you have for the latest cut, but you need to know what the total number from the previous cut is, So I said the total is equal to pi minus 1, or you call the function again and say total minus 1. It gives you the minus 1 edge.
Mm-hmm.
And
So what is the base case here?
the base case is total is greater than 0. So when you get down to no slices, basically, you hit the base case.
Right, okay. So if I call this with, oh man, I truly do not know Perl. But if I were to call this with pi 3, I would expect the result to be 7, because 3 cuts can yield 7 pieces.
Yeah.
So let's step through that.
Okay, you want to step through it from here? You can see my cursor? Yes, no, maybe so?
Yes, definitely.
Okay, yeah. So this is a cheaty way of saying I'm taking the input from whatever. Is equal to whatever you're calling pi with.
So
and then I make, yeah, it's equal to 3 for now. And then I set total equal to it. It's an unnecessary step, but I like having it there.
Mm-hmm.
And while total is greater than 0, so as long as you don't have like a negative number or a 0 or anything,
Mm-hmm.
You should be able to do this. If it is, it'll say your current total is equal to whatever the pi calling minus 1 is. So it would be you're recursing back to the top with a value of 2,
Mm-hmm.
starting with 3, and it's going to go down there and it's going to hit total again,
Mm-hmm.
and it's going to recurse back up here with a value of 1,
Mm-hmm.
and it's going to get all the way down here. It's going to say total is equal to 0, so it's going to say, okay, it's not greater than 0 anymore. Let's call the return statement, and that will return. What's the word I'm looking for? That'll return the current value. So since the first one's 0, it's going to be. I think I made an oopsie. It should be plus equals.
Aha.
Yeah. That way it accumulates every time, and it should go back to the top after this and fulfill all the values.
All right. So since the base case pi is 0, we got down there, and it's going to return 0 then because we passed in 0. So 0 cuts 0 pieces. 0 doesn't matter. It's the base case. But if we're returning 0, that means when pi 1 is called, total will plus equal pi 0, which is 0. So the total will be 0 again. So when we go back to 2, yep.
Yeah, that's right.
So when we go back to 2, that means total will be pi 1, which is 0. So total will again be 0. Basically what I'm seeing is when you call pi 0, that ends up being 0, because total was 0 when you pass it in.
Yes.
Pi 0 is total plus equals 0.
Mm-hmm.
Pi 1 is total plus equals 0. But when pi is 1, we have 2 pieces. 1 cut is 2 pieces.
Oh, you're right. I made a mistake there. How can I amend that situation? Let's see. Two slices. Make a special case for it, I guess. I could do greater than 1. Copy paste because I'm lazy. Total equals 1. Total plus equals pi. Actually, I don't even need to have an else statement here, come to think of it.
Mm-hmm.
That should still work.
Mm-hmm.
And if it calls this, total plus equals 2.
All right. Oh yeah, sorry about the no comments. So then pi 2 is 2 plus equals 2, and then pi 3, 3 plus equals, 3 plus equals 4. So yeah, this looks pretty good. This looks like it works.
Yay.
Very, very nice. Um,
Less hurtful
as,
than
as
binary.
an as an exercise to the reader and perhaps you, although our time is up, if you are so inclined, afterwards try to implement this algorithm in constant time without looking up the answer, just as a fun thing if you're into that. This can be done in constant time instead of recursion. But we are out of time, unfortunately, and I have a meeting to get to. Different time zones on the West Coast. But Jake, thank you very much for interviewing.
Yeah, thank you for interviewing me. I appreciate it.
Absolutely, I was very, very pleased with the progress you made on the problems.
Fantastic.
As for everyone else, thank you for watching. Uh, I believe there's going to be another one of these probably next week. Don't quote me on that. But we'll have someone else interviewing the next chapters in Cracking the Coding interview. And as always, if you have questions about today's mock interview, please tweet at us, which Twitter is, oh, I forget the Twitter. One sec. The Twitter is at the LSH Storm. So at the LSH Storm, which is for Lady Storm Hackathons. All right, so thank you everyone, and we'll see you next time.
Bye, Glenn.